Okay, we're going to start Chapter 7, Exponents and Polynomials. So first up is 7.1 on exponent rules and properties. So if we have an exponent, a to the n, a is going to be our base, and n is going to be our exponent. So when we're doing these, we always have to look at the bases, kind of like when we have um, like values, like terms, and then we have to look at the exponents, okay? And when we're going to work with these, what we're going to do is we're going to simplify the exponents in a problem. So what's going to happen is all exponents will become positive. We're going to have only one base, so each base is going to occur only once. So if we have bases in numerator, denominator, you multiplying by them and all kinds of stuff, you're going to simplify it down until there's only one base. So if you have A's and B's and C's, you only have one A, one B, and one C to whatever power. There's going to be no parentheses, so we're going to get rid of all parentheses, and that's just going to take care of all the powers. And there's going to be no power to a power left. Okay, so these are the key things that we're going to work with, and we're going to do it using 9 different power rules. Well, let's start off with something simple. So say we have x to the 4th times x squared. Well, what is x to the 4th really? Well, that's just x times x times x times x. And x squared is just x times x. So really we have 1, 2, 3, 4, 5, 6 x's. So that's really just x to the 6th. And we're going to find out soon that when you multiply, we have like bases here, x and x. And when you multiply those together, what happens is it's going to be the same base, and then we just add the powers. So then we're just going to take and add those two together to get the 6. And that's one of our power rules we're going to see here in a little bit. All right, so rule number 1, like I said, we have 9 of these. So we have a product rule for exponents. So if we let a be any positive real number and n and m be any real number, then this is kind of what we just saw. A to the n and then times a to the m is equal to a to the n plus m. So we had our x to the 4 times x squared, and then we had x to the 4 plus 2, which was 6. That's how this is working here. Now, rule 2 says the quotient rule for exponents. So let a be any positive real number and n and m be any real number. Then if we're dividing instead of multiplying, we're having a to the n divided by a to the m. Well, that's just going to be equal to the base, to the n, the numerator, minus m, the denominator. So now we're just going to take the numerator minus the denominator, and that's going to be our exponent. Okay. Now, rule 3 says the power rule for exponents. Let a be a positive real number and n and m be any real number. So then we're taking some base a to the n power, and we're going to raise that to the m power. And what's going to happen is that's just going to be the base, which was our a, and then it's going to be the n times n. So now we're going to multiply. So when we're taking power to a power, we multiply. When we multiply base times base, then we're going to add their exponents. So that's a key thing to remember. Add when you're multiplying, and when raising powers is when we add when we're multiplying, and then here we multiply when we're taking power to a power. All right, so then a power of a product rule, sometimes they call that a pop. Let a and b be positive real numbers and n be any real number. So then if we're taking some base a and times some base b, when we're raising that whole thing to the power n, what happens is that n gets distributed throughout. So then it becomes a to the n, b to the n, okay? Now, if we have rule 5, we have the power of a quotient rule, and that kind of works similarly. So if we have a and b be positive real numbers and n be a real number, then what we do is we have a over b, and that's all raised to our power n. What we're going to do is we're going to take that, raise it to the power, and that to raise to the power. So it's going to be a to the n divided by b to the n. Okay. Now, one of the nice rules, zero power rule. Let a be a positive real number, then a to the 0 is equal to 1 by definition. So basically, anything we raise to the power 0 is going to be 1. It doesn't have to be a real number. We can have a to the 0, actual value a, our letter, and raised to the 0, that's just equal to 1. So that's going to help us solve a lot of problems really simply by just making a whole big conglomeration be equal to 1. Then we've got a few negative exponent rules, okay? So rules 7 through 9 are the negative exponents. So if we let a and b be positive real numbers and n be any real number, rule 7 says if we take a to the negative n, again, remember, one of our things was we want always positive. Well, that becomes 1 over a to the n. So basically, we're going to take it to the denominator, and then make it a positive value. Now, corollary to that is if we have a to the negative n in the denominator, we're going to take it to the numerator and make it positive. And so really this is a to the n over. Basically, we've taken the reciprocal here and we've taken the reciprocal here, and then we made our powers positive. Now in this one, what we've done on rule 9 is we have some fraction a over b raised to the negative n. So what we can do is we can say, okay, well, let's make it a positive n and take the reciprocal. So now that becomes b over a. And now we can use our power of a quotient rule and say, okay, well, that's now b to the n over a to the n. And that's going to be our final answer. All right. So those are our 9 rules that we're going to stick by. And so now what we're going to do is we're just going to do some examples on and solving and simplifying exponents. All right, so the first one we're going to do is, if I can get my pen here, we have 1. All right, so let's say we have 4 times 2 squared. All right, well, here we don't have like bases, but we know what is 4. Well, 4 really is just 2 squared, and then that's times 2 squared. So we have like bases, and so what we're going to do is take and have our like base, and we're going to add our powers, because when we multiply like bases, we just add powers, so it's going to be 2 plus 2, so that's 2 to the 4th. Okay. Now what about the next one? Let's say we have, let me get my pen here. Let's say we have 2m to the 4th n squared times 4nm squared. All right. So that's a squared, so let's make that a little prettier maybe. Oops. All right, so let's look at numbers first. We have a 2 and we have a 4. Well, that's really just going to be a 2 times. Now, if we rewrite that like we did up here, that's going to be a 2 squared. Then we have m to the 4th times m squared, so kind of putting them together, what we have. And then times n squared times n. So that makes it easier to see kind of the bases by each other, and then we can remember and add our exponents. All right, so what do we have? Well, we have 2, and this is really 2 to the 1st, so we have 1 plus 2, that's 3. M, we have 4 plus 2 is 6, and n, 2, and when we don't have anything there, that's just assumed to be a 1, so that's going to be a 3. Okay, so this long thing becomes 2 cubed m to the 6th n cubed. Now the key thing is we've now made all of the things positive. There's no negatives here. We've only got one of each base, and so we basically followed all the rules we need to do to get those simplified. So let's try another one. How about one with powers? So let's say we have 4 to the 4th, and that is squared. Okay. Well, 4 to the 4th squared. Well, what we're going to do is we're going to take and raise that to the power. So that's really going to be 4 to the 4 times 2, which is equal to 4 to the 2 times 4 is 8. And so then that would be our simplified answer. Now, if they had told us to break it down even further and say, well, what is 4? We could do that, but not always is that the case. They don't always want us to make it as simple as possible. So 4 again is 2 squared, and that's raised to the 8th. Well, what does that become? Well, that becomes 2 to the 2 times 8, so that's going to be to the 16. So this is equal to this, but a lot of times, really, they want you to just stop there because all we were doing was taking a power to a power, and so they just wanted you to show that you could take the 4 times 2 and get to the 8. Now, we could have simplified like I showed here, and 4 is 2 squared, and that's still raised to the 8. And then it's 2 to the 8th, so that's 16. So that's something you might see. Sometimes they'll make it so you have to do all of it, but a lot of times they won't. All right, let's do one with fractions. Say we have 4x to the 3rd, y to the 4th, all over 3x to the 1st, y to the 3rd. Okay. Well, if we see our numbers here, we have 4 and 3. So there's nothing that's going to change there. So we can still go ahead and put 4 over 3, and that doesn't change. Now we have to kind of look here. Okay, we have x's on the numerator and denominator and y's as well. So what do? Well, we take and write those out. So x, and let's put y over here. And remember, when we have the fractions, we're going to take the numerator power minus the denominator power. So that's going to be 3 minus 1. This is going to be 4 minus 3. So now we can simplify that into 4. And then that's going to be x 3 minus 1 is going to be squared. And y is going to be 4 minus 3 to the first. So we can just leave it as y. And that's all over 3. And so then that would be our simplified answer to this problem here. And again, we just took found like terms, x's and x's, and subtracted their powers. 3 minus 1, we got the 2. And here we had 4 minus 3, and we got the 1, or the blank there, which is equal to 1. All right, so let's do another one. Let's do fractions with powers. So let's say we have 2x to the third over x cubed, and that whole thing squared. Okay. Well, we're going to work from inside outside, kind of like PEMDAS tells us to do. So first, we're going to take and get rid of the parentheses here by taking and raising both of those to the third power. So we're still going to have on the denominator x cubed. We're still going to have a squared out here. So now we're going to have 2 cubed. Then we'll have x cubed. Okay. So now we've simplified this. Now we need to simplify more inside. So now we have 2 cubed, and then we have x. Now let's subtract these. These are the same bases, so 3 minus 3. And then that's still all squared. Well, x to the 3 minus 3, that's x to the 0. Remember, anything to the 0 is 1. So this becomes 1. Now we just have 2 cubed squared. And when we have power to a power, that becomes 3 times 2, or 6. Okay. So this here, we had numbers and the variables, and when we got done, we just had only numbers. All right, let's go to another one. All right, how about, what number were we on there? 5, so let's do 6. 6, let's say we have q to the third r squared times, now let's say we have 2 p squared q squared r cubed all raised to the second power divided by 2p to the third. All right. So what I'm going to do is I'm going to simplify everything in the numerator, and the denominator is as good as it's going to get for now. So let's leave the denominator as it is. So that's 2p to the third. So now what we need to do here, it looks like, is we need to take each one of these and take it to a power. So we'll have 2 to the first squared. So it's going to be 1 times 2 is 2. So let's go ahead and write our q to the third r squared times 2 squared. Now we have p to the second to the power 2. So it's 2 times 2 is 4. So it's going to be p to the fourth. And same with q, it's going to be q to the fourth. And r is 3 times 2, so that's r to the sixth. Okay. Now we have things that are similar on top. So let's go ahead and bring our 2 squared out front. And then we have a q, so let's go ahead and put q. And that's going to be 3. And here we have a 4, so it's going to be 3 plus 4, so that's 7. And we have r, so we have 2 and 6, so it's going to be 2 plus 6, or 8. And we also have a p, and that only one is to the fourth. And then that's all over 2p cubed. All right, so now we have 2 in the numerator and denominator. So the 2 is going to be 2 minus 1, which is just 2. So we just have 2. Now our q stays the same. R is going to stay the same. Now we have p to the 4 minus 3. So 4 minus 3 is 1, so that's just going to be p, and so that will then be our answer. Now, if we've thought about this before, we've kind of done this in a different way. And so if we take this and rewrite it, q to the 7th, r to the 8th, p to the 4th, over 2p to the 3rd. Remember, when we cancel things, if you know there's a 5 in the numerator and denominator, we can do that. And so what we can do is we can say, okay, well, one of those 2's cancels one of those, and we have 1 left. 3 of those cancel 3 of those, and we have 1 left. And so now we have 2 to the 1st, which is what we have, q to the 7th, r to the 8th, p to the 1st. And so that's what we have there. We don't have to really do the 4 minus 3. We can just say, well, 3 of those cancel 3 of those, and there's 1 left over. So there's 2 ways to go about this when we have the fractions. And so depending on which way you like better, you can do it. Both of them will get you the same answer. All right, let's do another one. Let's say we have 2x to the 4th, y to the negative 2 times 2xy cubed, all raised to the power 4. Okay. Now remember, we always want positive exponents when we get done. So let's go from left to right and kind of rewrite what we have. So the 2 is okay, x is okay, so that's x to the 4th. Now y squared, that's to a negative 2. So what we want to do is we want to take that to the denominator and make it positive. And now we've got everything in here raised to the power 4. So this now is times 2 to the 4th, x to the 4th. Now 3 times 4 is 12, so that's y to the 12. All right. So now what do we have? Well, we have a 2 here and a 2 here. We have a 4 plus 1 is 5, so that's going to give us 2 to the 5th. And we have x and x, so that's 4 plus 4 is 8, so that's going to be x to the 8th. Okay. Now we have a y here and a y here. So we can either take 12 minus 2 is 10 and say, okay, that's y to the 10. Or we can say, well, 2 of those cancel 2 of those, and we're left with 10 there. So either way, we still get y to the 10th. Okay. And so then that would be our answer. All right, let's do another one. Let's say we have 2x to the minus 3y squared over 3x to the minus 3y cubed 3x to the 0. All right. So let's first start with, let's make all of our exponents positive. So we don't have any powers we're raising to or anything else. So let's make all our exponents positive first. So what that's going to do is it's going to take that x to the 3rd to the denominator. So that becomes 2. And this x to the 3rd comes to the numerator. You know what? Let's do something different. So let's not have them look the same. Let's do this. Let's say we have, instead of a 3 here, let's make this one a 4. So then we can differentiate where things are. So we have 2, and then the denominator we have our 3. So this x to the 3rd comes down here and becomes positive. We still have our y squared in the numerator. Now the denominator, x to the 4th, well, that's going to go to the top, and we have x to the 4th. Now here, y cubed is going to stay, and then we're going to have another 3. And x to the 0, remember, anything to the 0 is 1, so that's just times 1, or we can just leave it off, and we have finished basically simplifying that one. All right, now numerator and denominator. So the denominator, it looks like we have a 3 times a 3, so what we can do is we can say, well, there's a 2 here, and that's a 3 squared here. Now we have x to the 4th here, we have x cubed here, we have y and y. So if we just do the canceling, 2 of these cancel 2 of those, we're left with 1. 3 of these cancel 3 of those, we're left with 1. So on the numerator, we have x to the 1st. Denominator, we have y to the 1st. Or if we want, we can just say that's 2x over 3 squared y. Now, one thing, some of the problems eventually are going to ask you to multiply it out. So that really would be then 2x over 9y. So sometimes they'll ask you to multiply it out. Sometimes they want you to keep it as the exponents. So you have to be careful on those to see what the program asks you to do. All right, let's do some more. So now we're ready for number 9. How about 2y over, and now we have parentheses x to the 0 y squared to the 4th. All right. Well, all we have to do is work in the denominator. Well, x to the 0, that's just 1, so we don't have to worry about that. And 1 to any power is just going to be 1. So this becomes 2y over, now y squared raised to the power 4, so it's going to be 2 times 4 is 8, so it's going to be y to the 8th. Now, what we can do is we can cancel. Well, one of these y's is going to cancel one of those. That's left with 7. And so we end up with 2 over y to the 7. Now, if we had done the exponent rule and subtracting and all that, what would have happened would we would have had 2y, and this is 1, so it's going to be 1 minus 8. And so then that becomes 2y to the negative 7. Then we had to use another power rule. It says, well, to make this positive, we take it to the denominator. And so that becomes 2 over y to the positive 7. So if we just followed power rules only, this is how we would go, and we'd get the same answer. But if we did the simplifying, okay, well, one of those cancels one of those, we get 7. We keep positive numbers all the time in this case, and then we don't have to go through as many steps to get to our final answer. So either way is correct, just depends on how you want to work it and go about thinking and things like that. All right, so let's see. How about a couple more? Let's say we have m to the 0 times n to the 3rd times 2m to the negative 3 times n to the negative 3, all raised to the power of 0. All right. Well, we could go through here and say, well, m to the 0 is 1. Then we have n cubed, 2. M to the negative 3, that would go to the denominator. N to the negative 3, that would go to the denominator, become positive. But if we look here, we have a 0. So we've raised this whole thing to the 0. So anything to the 0 is 1. And so that's one of those simple problems. The answer is just 1. And so when you see something like that, you could work your way through it, but once you get to that end part, you're like, oh yeah, there's a 0 here. So be careful and watch for those, because sometimes they'll do that, and it's you make the problem complicated by doing all the things in between, but that tells you that it's just going to be equal to 1. All right, so let's do one last one before we're done with this lecture, then I'll do some example lectures as well. So let's say we have 2x to the negative 2, y to the 0, 2x, y to the 4th, all over x, y to the 0 to the negative 1. All right. So I'm going to do stuff in the numerator first. And y to the 0, that's going to be easy. That's just 1. This x to the negative 2, that's going to go to the denominator. So I can just leave it out. Here I have 2 times 2, so that's going to be 2 squared. Again, that went to the denominator, so I have x, we have y to the 4th, and then what do I have in the denominator? Well, here, y to the 0, that's 1. So I have x to negative 1. Well, that means I'm going to have to take it to the numerator, so that becomes x to the positive 1. And I remember I took that x squared down to make it a positive. And so now I think I've taken care of everything. Now I just have to simplify. So here I have an x times an x. So that's going to be 2 squared x squared y to the 4th over, and then I have my x squared in the denominator. Well, guess what? X squared cancels x squared, and I just have 2 squared y to the 4th. And like I said, sometimes they might say, okay, we'll multiply it out, so that would be 4y to the 4th. Okay, so that finishes the lecture for 7.1.